permutation. Question is, determine the number of distinct ways to arrange 4 books on 3 bookshelves such that order of the books on each shelf matches. That means we are arranging 4 books into 3 bookshelves such that order matters. Suppose these are our 4 books and these are our 3 shelves. We have 4 books. Let's suppose these are math book, science book, English book and history book, and 3 shelves. First is brown shelf, second yellow shelf, third white shelf. We are placing these books into these shelves. So it is permutation or arrangement problem. Situation is to place one book into one shelf. Here order matter, which books stays where, so it is permutation problem. Yes, we have already understood. Our purpose is to place these 4 books into these 3 shelves such that the order matters and only one books will go into one shelf at a time. Here now we are going to present first some examples to understand actually what we are going to do. These are the possible arrangement. This one arrangement, this is another arrangement, and this is another arrangement. It is sample arrangement. Now we proceed to discover all such possible arrangement. Here are 3 possibilities we have shown. How many are possible there? We will actually understand that. We will be more clear on what we are trying to do. Let us watch another demo. Let us watch another demo to be clear. This is one arrangement. This is another arrangement. What this means is that we can generate new permutation or arrangements just by easily changing the book's position on the shelves. We are placing all the possible books in the first shelves initially. There are 4 choices of books available to choose from to keep into the first shelves. That means we could choose either M book or S book or ebook or H book for the first shelf initially. Here we are attaching 3 shelves together to denote that each permutation or arrangement consists of 3 books. That is, each arrangement has 3 books together. We will understand it later. Now we are going to place the possible choices of books available for the first shelf. We can choose either math book or science book or English book or history book for the first shelf. Here we denote possible number of choices for the first shelf. There are 4 choices available. Next, we proceed to allocate the remaining possible book arrangement to the second shelf. Given that one book has already placed, there are only 3 books left to fill. One book has already been placed on the first shelf. We now determine the number and identity of the remaining books available for the allocation to the second shelf. This means that if there is math book in the first shelf, then we can choose either the science book, English books, or history book for the second shelves. Similarly, if there is science book in the first shelf, then if science book occupies the first shelf, then the second yellow shelf may be assigned any one of the following: math book, English book, or history books. There are three possibilities for the second shelves. And similarly, same situation happens for the English book or the history book. We remove the bottom part and we notice that possible number of choices for the second shelf is 3. Now we proceed to fill third wide shelf. For this, we first drag all the arrangement of books in the first two slots into the bottom and evaluate the possible number of weights to fill the third shelves. We drag all of these arrangement into the bottom part. All the arrangement we have discovered earlier. And if there is math and science book in the first two shelves, then we can choose either English book or history book for the third shelves. So there are two possibilities if there is math and science for the first and second shelves. Similarly, there are two books choices for the each of these possibilities for the first two shelves. We can clearly see from these visuals. There are two possible books to select for the third shelves. And we will fill all the remaining possible shelves accordingly. And we remove the bottom part. And similarly, we will fill all of the possible arrangement. And in this way we have discovered all possible arrangement. Thus there are 24 possibilities. Thus these are all the existing possibilities to arrange 4 books into 3 distinct bookshelves. Thus there are 24 possibilities. From the formula perspective, permutation of 4 objects chosen 3 at a time is equal to 24. Justification of the formula is that there are 4 possible choices of books to assign to first shelf. Then for each of these choices, there are 3 choices of remaining books to assign into the second shelf. And finally, for each of these possibilities, there are 2 possible choices of books for the third shelf. So total arrangement is equal to 4 by 4 times 3 times 2 is equal to 24. In this video, we have selected sales first and then we accommodate books into them. However, in the next video, we will calculate the same 24 possible arrangement taking the selection of books first. We will discover all possible arrangement implementing different method, and subsequently thereafter we will select 3 books to be placed on 4 shelves where the order in which the book shelves is irrelevant. However, the selection of the specific book is of primary importance. We will discuss accordingly. Stay tuned. Thank you for watching the video.